Hello dear friends, once again welcome back to Triple tutorial channel. Here we will see some objective questions, NCVT based objective questions for ITI syllabus. So let us discuss about that questions. Okay, so I selected some questions from a DC generator topic. So let us discuss about that questions one by one. Here the first question is, what is the principle of DC generator? Principle means normally it can be the working principle of DC generator. Here you can see for options corkscrew rule, Fleming's left hand rule, Fleming's right hand rule, and finally Faraday's laws of electromagnetic induction. I know that we are familiar with the working principle of DC generator, which is nothing but the Faraday's laws of electromagnetic induction. But we can go through these other three options also. So first, that is corkscrew rule. Corkscrew rule is also a rule which is related with the magnetic field and current. But if we place a screw on in our right hand, and our curled fingers will indicate the direction of magnetic field, then the head of that screw that will indicate the direction of current. So simply we can say that the corkscrew rule is used to find the direction of magnetic field around a current carrying conductor. Okay, magnetic field around a current carrying conductor. Okay, so next rule, that is Fleming's left hand rule. This rule is normally, Fleming's has two rules, Fleming's left hand rule and right hand rules. But this left hand rule is closely related with motor sections. Okay, so it is used to find the direction of force acting on a conductor. Okay, direction of force acting on a conductor when it is placed in a magnetic field. And Fleming's right hand rule is related with a right for generator. Okay, so this right hand rule is related with the generator to find the direction of current or EMF. Okay, so we should go through these four options. So the answer will be the the principle of DC generator is nothing but Faraday's laws of electromagnetic induction. So let us discuss about the second question, that is, which material is used to make brush in DC generator? Here you can see four options. Option A, steel and graphite. Option B, carbon and graphite. Option C, cast iron and graphite. Option D, aluminium and graphite. We can directly eliminate option A, option C and option D, because in option A the steel is there, and for option C cast iron is there, and option D aluminium is there. Normally these type of materials can be used as a conductor in electrical machines. Okay, their conductivity is very high. So these type of materials are normally used to make as a conducting material. So apt option is option B, that is carbon and graphite. These two materials are commonly used for the production of brush in DC machines, not for DC generator, but for DC machines also we can use this carbon and graphite. And we know that these carbon and graphite, both materials are two forms of the same material. Okay, but carbon is having high performance level of carbon is very high and light in weight, and the durability of the carbon is very good, and durability is very high. Okay, durability is very high. So these are the main characteristics of carbon brush instead of this when compared with the graphite. And for graphite, we know that highly lubricating, and conductivity is very good than that of carbon. Good conductivity and good heat resistance. Or we can say high temperature resistive material. That is, graphite is having high or excellent lubricating property and having good conductivity. Heat or temperature resistivity is very high for graphite. Due to these properties, normally carbon is used to produce brush in smaller capacity machines. Normally carbon is used, but for larger machines, electrographite brushes are normally used. Electrographite brushes are used. Okay, that's all about this question. The third question, that is, which material is used to make pole core of large DC generator machines? Okay, pole core. We know that the function of pole core is to provide necessary flex to the motor. So they will carry some field windings, and these field windings will provide necessary flex for the proper operation of the DC machines. Okay, so it is very important for the selection of the material for the production of pole core. Here you can see 4 options: soft iron, cast steel, and stainless steel. So we know that for larger machines, normally cast steel is used for the production of pole core. But for smaller machines, normally cast iron is used for the production of pole core. In addition to this pole core, for the production of yoke, we can use cast steel. For larger DC machines, for the production of yoke and pole core, we can use cast steel. But for smaller machines, for the production of pole core and yoke, we can use cast iron. Normally, we can use this cast iron. Okay. So we can discuss about the fourth question. That is the last question in this PPT. So which material is used to make large capacity DC generator yoke? Already we discussed about the production of yoke, large capacity DC generator, that is nothing but cast steel in the previous slide. But in this option, you cannot see that cast steel here. But you can see cast iron, soft iron, aluminum, and rolled steel. So in this option, we can select a rolled steel as the production of yoke for larger capacity DC machines. Okay, if in the option cast steel is there, that is the exact apt answer. If it is not there, you can select a rolled steel as the answer. Okay. So thank you, my dear friends, for listening me, and in the coming lessons we will see some questions based on this DC generator and all electrical topics. So tune for that, and once again, thank you.